Welcome to our fourth recorded lecture for Computer Programming 2. In this lecture, we're going to start our example talking about cars, and we are going to create a class called driver, create a class called car, and then extend that class 3 times, once with Neon, once with Cavalier, and once with Prius. We'll start with a brand new project, even though this will be almost identical to what we did in Computer Programming 1. Once again, a reminder, the slides that we're going over, some of them we might look at, some of them I might just discuss without actually looking at the slide. But they're under Computer Programming 2, and then under the Inheritance section. So here's NetBeans, and I'm going to create a new project. We'll call the project vehicles rather. Okay, I had to do a little bit of reorganization there, so let me start that again. New Java project. That's a nice thing about recording these classes in advance is that if I have an issue, I can just crop it out of the recording and I don't waste your time. In this case, I already had a project named Vehicles, so I just renamed it. So Vehicles. There we go. That looks better. No message now. Remember that this is what we're going to call a package here. Vehicles and then a period. The period isn't part of a package. It just separates different directory structures. After that, we'll have the class which has the main method, which in this case is going to be our user interface class. So we'll call that driver. Okay, I think we look good. And then I'm going to choose finish. To be honest, we could take care of the user interface stuff here in vehicles driver right away, but I think it's easier to start modeling the noun classes first. Like the one we're going to have is called car. Last quarter I called it vehicle. This time we're going to call it car. So I right click, choose new Java class. Remember that our noun classes should be separate from user interface anyway. I call it car. Everything else looks good. I choose finish. Now over here, I'll refocus the editor here. I'm going to declare some attributes. We're going to say int odometer, double gallons of gas, and int mpg, or miles per gallon. We'll spell it out. I'm going to go through this a little faster than I did last quarter because we've already seen it. I'm just trying to replicate it. Remember to create getters and setters. First of all, let's make sure our data types are correct, because the getter and setter methods are going to be based on those data types. In this class, I'm going to do some mathematical computations, so I want everything to be a number. So int, double int, everything's a number, looks pretty good. I'll right-click, choose refactor, and encapsulate fields. And remember from our first or second lecture, we talked about encapsulation, how this is an important concept in object-oriented programming. It's a lot like trees and stomata on their leaves, which open up, let vapor out, which creates a vacuum and brings water up from the ground. In that vacuum, it brings magnesium, which is one of the elements that's used to make chlorophyll, which is why trees can grow to be up to a few hundred feet tall and still have green at the very top. And so encapsulation is a very important concept, because it is that protection like the stomata that decides when there's a drought to close up and not let water out, but then when water's plentiful, they'll open up and let water out. So I choose encapsulate fields, and I'm going to choose yes. Fields visibility, normally we'll make it private. In this case, I'm actually going to change that to protected. And right here you see, when it says field, it means those attributes. Right here you see the four access modifiers that are permitted in the Java programming language. If you're thinking quiz question suggestions, this is an excellent suggestion because I know I have a quiz question in the pool that is exactly this, which is what are the four visibilities? Public means it's accessible to all classes everywhere. Private means it's only accessible within this class. That means these attributes can only be directly accessed from within this class. We see two others now. One is protected. Protected is somewhere between public and private. Protected means it's visible to this class and any subclass of this class. In other words, it's available or visible, can be used directly by this class as a parent class and any children of this. A little footnote, it also is usable by any other class in the same package. I wouldn't make something protected and use it anyway. I would prefer to make it private if you're going to do that. Default, you see it has the greater than, less than. That's because default is what we get if we don't specify anything. And a lot of people don't know what this is. The vast majority of people have no idea what it means. If you don't specify a, a visibility level, in other words, if you don't specify an access modifier of public, private, or protected, you get default. And default means it's available or visible to any other class in the same package. It is the default visibility that you get, but what's weird is I don't know why anybody would want to have something, an attribute or a method that's visible to classes within the package but not other packages. That kind of opens up a bit of a security hole. So I would prefer they'd made the default either public or private. But in any case, these are the 4 access modifiers. The ones you'll use the most common are public, protected, and private. We usually make attributes private, but I'm going to make these protected because remember the rules of inheritance. Inheritance means that methods and attributes are available to a subclass as long as they are defined as non-private in the superclass. Protected is not private. Public is not private. Default is not private. As long as we have any of these selected, then the attributes that we're defining here will be visible to our subclasses of class car. In other words, think of that UML diagram. We're defining car now. It's extended by Cavalier, Neon, and Prius. I want to make these attributes available to those classes. I'm going to make it protected. We'll keep the accessor or the getter and setter methods. We'll keep those as public. I'll choose select all because this will automatically generate all of the getters and setters for each of these attributes. And then I simply choose refactor, sit back and relax, and it's done. The next thing I want to do is define the method called go, public void go, which will accept a distance as an int. And we remember what this is going to do. I'll put some java.comment comment up here. By the way, in your programming assignments, when I say comments, one thing I'm specifically going to be looking for is java.commenting commenting like this, which goes above a method. You get it for free. If you do the slash on the question mark key, 2 asterisks, and then hit return, it will automatically format it. What you do in JavaDoc is you put a description of the method here. Move the car the specified distance. And then down here we have param. You can define what these incoming parameters are. So param distance, how far you want the car to move. What's nice is that that then becomes part of the context-sensitive help. So in other words, when you're in driver and you access Go as a programmer, it will bring up this java.comment so you can see what the Go method does. Okay, so now I'll say, well, if we move a distance, we're going to say odometer equals odometer plus distance. Okay, we want to increase the odometer by the specified distance. Okay, and then we want to compute gallons of gas used. Okay, so we'll make a local variable, double gas used equals distance divided by miles per gallon. So if we get 25 miles to the gallon, we drive 100 miles. It means we've used 4 gallons of gas. And then we use the shortcut operator here to say gallons of gas minus equals gas used. That just says subtract gas used from the current gallons of gas. Okay. Compute the new value of gas used. Okay, one more method we're going to want to make, and that is public string to string. And this will just return a string representation of the state of this object. Okay, for that we'll say string state equals odometer, okay, plus odometer, plus gallons of gas, plus gallons of gas. Okay, return state. Because remember, if we have a return type defined, like we do here, the very last line of the method must be a return statement. Many times people give me red lines, tell me they have red lines, and the reason is they do something else after that return. You can't. The return has to be the last line of a method. There is a little exception. If you have it within an if test, you can make it part of an if test. But in general, let's just say for our purposes, you really want the return to be the last statement. It makes the method much more readable anyway. So if you get a red line like that, ask yourself, is the return statement the last line? If you get a red line like this that says missing return statement, take a look at the return type here and make sure that you do have a return statement that matches at the very end of the method. At this point, our car is essentially done, and we will make a few subclasses of this, but first we'll go back and work on the driver. Now moving to our user interface class. This class is in charge of all interaction with the user. You'll notice in car I don't have any JOptionPane and I don't have any system out print line. And that's what I expect to see in your programs too. In account savings checking CD, there shouldn't be any system out print line, shouldn't be any JOptionPane. All the user interaction should happen in the banker class. And also remember that the toString method returns the state of a car, so we can call that from driver if we wish, if we want to show the state of our car. Okay, as we do before, we'll make a method called promptUser. Okay, and open curly, close curly. Of course, we want to make sure that we put the promptUser method within the class, which is defined as this, the open curly and the closed curly that begins the class, but not within another method. We want to give it, we'll make this, we can make this private, static void prompt user. And now we also want to make sure that we call or invoke prompt user from the main method. Because remember, the main method is where the program begins. It's going to direct everything and tell everything to do what it needs to do. Okay, so I'm going to put in a do while loop. And remember, a do while loop is often used when we are prompting the user because we know that it's going to occur at least one time. Okay, since the test is at the end. We're going to take a little shortcut here. We remember in the past we've said int user response. We'll declare a variable up here. And then we would say something like JOPC. Remember that shortcut we made where we can do a JOptionPane show confirm dialog. And then say, do you wish to enter more cars? Okay, and then more cars. Okay, and we'll assign the result of this to our user response, like so. Control-Shift-O to organize imports. Okay. Oh, let me save. Oh, I'm sorry. I just gave you an Eclipse shortcut. That's not going to do you any good. Don't Control-Shift-O. That only works in Eclipse. Click on the light bulb to organize imports. Okay, and that will import our JOptionPane as we see up here. It imports it from its proper package. Okay, now what we would do in the past is in the while loop, we'd say while user response equal JOptionPane dot yes. Hopefully it'll find this constant. Yes option. This means did the user, well, I need to spell it correctly. So we declare a variable here, and then we assign it here on 29. If the user chooses yes, the user response is going to have one value. If the user chooses no, that's going to have another value. Okay, what we're doing down here is we're saying, is the value returned in user response the same as the yes value? Did the user choose yes? That will certainly work for us very well, but we can shortcut this. we can do a little shortcut which cleans it up a little bit, and that is we just say this. I'm going to take the JOptionPane show confirm dialog, except for the except for the terminal parenthesis, and I'm just going to do a comparison and a prompt right here in the while. So it's a shame I can't show this all on Screencast-O-Matic, but notice the while test, while, and then within the while test, we're showing this show confirm dialog, and then we're comparing the result of that to JOptionPane.yes option, which says prompt the user right here in the while test, and then see if the user said yes. If the user said yes, go again. If that whole last 5 minutes was confusing, don't worry about it. You can do it the old-fashioned way. I just wanted to show you, if you want, you can do this all in one line, where before we did it in 3 lines. So, fielder's choice, do it as you wish. If that was confusing, don't worry about it. Do it the way you're comfortable with. If you prefer to do things in one line, certainly you can do that here as well. Okay, I'm going to make a collection of cars. I'll say array, let's say private static array list, and then the car in the greater than less than says this collection is going to store cars. We'll call it all cars equals new array list car, open and close paren, terminate with a semicolon, and then click on the light bulb to import the array list. Okay, now what we'll do is in our do while loop, we'll say car, my car, equals new car. Okay, so we'll say declare and initialize the car, the my car variable. Okay, and then we'll say, whoops, and then we'll say prompt the user for information and convert that information to the proper data type. Okay, so the UI class is in charge of prompting the user for information and also for converting it to the proper data type before we call the setter on my car. So we'll say JOptionPane, show input dialog, what is the odometer reading? Okay, and we'll say string str odometer equals, just like so. And then we'll say double, or no, that was an int, right? Int odometer equals integer dot parse int. Remember, this is how we convert a string to an int. And remember, JOptionPane can only return strings. If you were to try to make this guy up here, if you just declared him as an int, that would not work, because JOptionPane show input dialog can only return a string. It's up to us to convert it to the proper data type. Okay, str odometer, terminate with a semicolon, and then my car, whoops, dot set odometer. And NetBeans was kind enough to figure out what we want to push into that setter. Okay, we do this 2 more times, once for gallons of gas and once for miles per gallon. String str gallons of gas equals JOP tab, how many gallons of gas? Okay. Double dbl gallons of gas equals double dot parse double str gallons of gas, terminate with a semicolon, my car dot set gallons of gas, and once again NetBeans is kind enough to figure out what we want to pass into that setter. Okay, final one, string str miles per gallon equals JOptionPane show input dialog, how many miles per gallon. Okay. Int miles per gallon equals integer dot parse int, oops, str miles per gallon, terminate with a semicolon, my car dot set, whoops, dot set miles per gallon, boom, there we go, int miles per gallon. So now we've prompted the user for information and we've stored it in the car, and now we can store the car in the array list, or let's say the collection. Okay, all cars, Now to add an item to an array list, we simply choose Add. Once again, NetBeans has been kind enough to figure out for us what we wish to store in this all cars collection. So there we go. This is our prompt loop. Let's make a print loop as well. We'll say print data or print cars. Okay. And down here we'll say private static void print cars. Okay, open and close paren, open curly and close curly. And I'll say iterate over the collection of cars, and let's say move them and print their state. I should probably also put some java.doc comment up here on prompt user. Prompt user for information needed to create a car. Create a car object and populate it with the user's information. Let me add one between those two. Whoops, sorry, don't know where that came from. Okay, convert data to the appropriate type, string to int, for instance. Okay. Okay, and then let's say add the car to the collection of cars. That's probably a little more detailed than we really need to go for this method, but naturally I'll post this when I'm finished to Blackboard, and I want to have something that you can study from. Okay, print cars, we're going to say FORE, which is the NetBeans shortcut for iterating over a collection. Quite nice. And now what's going to happen is for each item in the all cars collection, we're going to store the latest version in a variable named car of type car with a capital C. What we'll do is we'll say print the state of the car, system out print line, car before running. Okay, and then we'll say car.toString. There we go. Now let's say run the car 100 miles. Okay, car.go. Take a look at this. Do you remember this? Move the car the specified distance. Distance, how far you want the car to move. That's the Java documentation we put in the go method when we made the go method. And I mentioned that it would be visible in the context-sensitive help when we called it from another class. And this is what I mean. This is where you can see it. It might seem kind of simple if you have a class that only has, or have a program with only 2 classes. But trust me, when you get into an industrial strength application, like the one I deal with every day, which is a point of sale application, there can be tens of thousands of classes and hundreds of thousands of methods. And the Java documentation can be very helpful in deciding which method to call. So we tell it to go a specified distance, we'll say 100, and then we'll print the state afterwards. I'll just do a quick copy paste job here, and there we go. Okay, and we save. Now again, this is exactly what we went through in Computer Programming 1, so I'm going to go through this a little faster than we did back then because you've already seen this. If you do want to see it in more depth and a little bit slower, I can point you to the recorded lectures I did just a few weeks ago when I taught the quick Computer Programming 1 course. So given that, I'm just going to run it. I won't debug. We'll just kind of do some math in our head. Make sure everything worked right. Now this is very interesting. I have to give you a little side note here while the debugger's running. There we go. If you had me for Computer Programming 1 last quarter, you know I'm spending most of the summer in Mexico, part of the summer in the United Kingdom, and only a little bit of the summer in Cincinnati. I'm in Mexico about an hour and a half to 2 hours south of Texas recording this, and it's in a desert community. I'm in like Nevada. It's the city of Monterrey, which is the second or third largest city in Mexico, and I'm not downtown, but pretty close. I'm basically what Covington is to downtown Cincinnati. That's about where I am right now. It has been incredibly dry in Cincinnati this summer, but in Monterey, it has been incredibly wet, especially for a desert town. And what's funny is that because it is a desert town, they don't really have sewers that are very big on the streets. And I just looked out I'm in my hotel now, looked out the window and it's raining. And it's been raining quite a bit this summer. And because of their sewer system, to them, rain is what snow is to us. They don't like driving in it. It's like us driving in snow. So I just happened to catch a glimpse of that out the window here. And anyway, side note, but interesting nonetheless. So, okay, what is the odometer reading? We're going to say 10,000. And remember, we're going to move the car by 100 miles. So what we're going to expect is on the first state, we're going to see 10,000. On the next state, we're going to see 10,100. How many gallons of gas? Let's say, again, 10. How many miles per gallon? Let's say 25. Now, we're going to run at 100 miles, remember. So we will expect the before state to show 10 gallons of gas, and then the after state to show 10 minus 100 divided by 25. In other words, 10 minus 4, or in other words, 6. Okay, let's go ahead and enter one more car. This one, we'll give it an odometer reading of 20,000. We'll give it 20 gallons of gas and miles per gallon of 20. So 100 miles divided by 20 is going to be 5 gallons of gas used. So we expect the after state for this vehicle to be an odometer of 20,100. A gallons of gas of 20 minus 100 divided by 20, or in other words, 20 minus 5, or in other words, 15. Okay? Now remember, this is our little yes-no, the show confirm dialog. This is actually running in the while test. If I click yes, it returns one integer. If I click no, it returns a different integer. And we don't really care what the value of that integer is because we can just compare it to the constant yes option, which is what I'm doing here. This loop will continue to execute as long as what I chose equals the yes option. As soon as I choose something that does not equal the yes option, this becomes false because we're doing a double equal comparison, and whoops, and the loop terminates. Okay, so this time I'll choose no, and let's take a look at our state that results. There we go. The car before and excuse me. So before the first vehicle, 10,000, 10 gallons of gas. After, odometer 10,100, 6 gallons of gas. Before for the second vehicle, 20,000 on the odometer and 20 gallons of gas. After, 20,100, 15 gallons of gas. Everything's working as designed. So given that, and that we're almost on the 30-minute mark, I'm going to go ahead and save this lecture, and then we're going to start a new lecture. And the new lecture is going to be new material that talks about how we can extend car into a Neon, a Cavalier, and a Prius. So we'll start that second lecture. Don't forget to do I guess that will actually be our 5th lecture for this class. Don't forget quiz question suggestions. Thank you.